The difference between the two. Gotta find it here, hold on. Can we leave all these out for Lisa to deal with? When she gets back? Did you guys get your little video watch yesterday?
No.
No.
Okay, these are both been used, so it's kind of hard to see it exactly. The one on the bottom is a machine screw. And so the thing being, it looks like it's chamfered here, that's just been worn down. It's actually, the threads will come straight out to the end where it's just been cut off. On a cap screw, which is this one, they're always chamfered by default. Now, why would we chamfer that edge?
Goes on easier?
Yeah, it seats it, right, in the fastener it's meant to go with. Makes it easier to put them together. Let me see, this one might have a sharper edge. This one hasn't really been used much. Yeah, this one's got a straight edge on it. It's a little bigger for you to see. So here's a machine screw.
Oh.
Now, since you folks haven't seen your video, how do you know the difference between the two? What's the difference between a machine screw and a cap screw?
The 45-degree angle.
It's one difference, yes?
Looks like one.
The big indicator is machine screws are threaded all the way to the head. These are not. Okay, so whenever you're doing one of these, the cap screw, you chamfer the edge. You can chamfer machine screws, but it needs to be called out with the note if we need it. Generally, we don't.
Is there a certain distance for the cap screw to leave?
Yes. Yeah, so let me put this up here so you can see it. Yeah, and when you're looking at drawing one of these, and I wasn't going to take my drawing that far today. I was just going to do the threaded portion. But if you're drawing a cap screw, how far do you know the threads come up? It's a formula. If I remember right, and I may be slightly off, I always look it up to make sure. I think it's 2 times the diameter plus 1/4 inch. So if this is a 3/4 inch diameter, it would be 2 times 3/4, 1.5 inches plus 1/4, so this would be 1.75, 1.5 inches. And then we just call out the length. Now, the reason these are different, right, this is probably some material, we got a washer and a nut to hold the two together, right? That's what that's used for. All right, I think that's the major terms on them. Now, let's just, real quickly before we go, we're going to look at the different types. So let's go to page 920. Right at the top of the page here, they've got some external fasteners, and you can draw them 3 different ways. Now, the end view, or the circular view, is done the same for all 3. Okay. So you see the major diameter, and then on this one you're seeing the chamfer, which is equal to the minor diameter. They're both with object lines, because I'm looking right onto it. If I was looking into the head, those would be hidden. Now you have 3 methods: simplified, schematic, detail. Let me give you the ANSI standards right off the start. Simplified is the ANSI and ISO standard of thread representation up to 1 inch. 1 inch diameter. So we use simplified. So that's for everything up to a diameter of 1 inch.
What changes that for 1 inch?
At 1 inch, we do a detail representation. Because now the object's big enough that we can see the detail of the thread. I love these things. I still remember to this day, the first time I saw a drawing of one of those. I was working, you know, and I hadn't really done it. I was down in Nevada working, saw one, this drafter put together. That's so cool. They look awesome. They look just like a thread. How'd you do that? I made him sit right down there and show me how, and then copied some stuff out of his textbook and went and practiced it. Been on my drawings ever since, right? Because they look cool. So the thing is, this one's easy. Right? Takes you just a couple seconds. All you need is major and minor diameter. That's all you need. To move to the detailed, it's only a couple extra steps. Looks much better. You need the major and minor diameter and the pitch. So you got to add one thing that you need to know. With a little bit of practice, you can draw the detail pretty much as fast as you can draw the simplified. The schematic is no longer even in the categories, which I am very happy about. Nobody liked the schematic. What it did was it had these bold lines in the middle that represent the minor diameter, and then thin lines on the outside to represent the major. But you would draw it like that at one line weight, and then what happened when you scaled it? You'd have to adjust all your line weights, because now you'll see them come out and they're just black messes or stuff like that. Thank goodness this guy's gone. You will see it on old ones, old drawings. Pre-1996, I believe, 94, somewhere in there they made that change. So, simplify. Object line on the outside to represent the major diameter. Hidden line on the inside to represent the minor diameter. Thin line if it's chamfered. Detailed thread representation. You're going to want to play with these line weights a little bit. For the most part, I use the text layer for my tooth profile. And then as I come across the body of the thing, I generally do my root lines at like a 012 and my majors. It depends on the size I'm printing it and how it's going to look. They give you the same stuff down here, whether it's an internal thread, how it's sectioned, how it should look. Pay attention to these if you section them. Because like even on the simplified, notice that the major diameter's in the hatching. And that just follows orthographic projection rules. All right, so we're going to take a break now. Are there any questions on what we've talked about, the terminology? This will be synonymous. You're going to hear me mention these terms over and over and over again, and try and get in the habit of you maybe mentioning them too when you're talking about it, because we say, hey, I'm going to draw a detailed representation, major, minor, pitch. You need to know those three. All right, so let's take a break. We'll come back and we're going to draw a simplified, and then we're going to draw a detailed.